So now we discuss few more example on your binomial distributions. Find the mean of binomial distribution P4 1 by 3. So this means your the binomial distribution is represented by your NP. So here N is your number, maximum value of random number. Your N is 4, number is 4 here, and probability of success is your 1 by 3. So as such, if we interested to find the mean, so we know that the mean is your N into P. Just multiply these two values. That is 4 by 3, which is your required result. But if a question asks find the binomial distribution, or you say distribution first, then find the mean, then we have to do some calculation work. Because when you say distribution, about the distribution means we are interested to find the value of your random probability of random variables at 0, 1, 2, 3, and up to n. That means here up to 4, and that this table is called your probability distribution, and we are interested for particularly binomial distribution. That means your this probability function is binomial. So that is your NCR e raised to r q n minus. What is this function? If you remember, that is your NCR is total number, r is your favorable cases, probability of success raised to power r, and q raised to power n minus. So here n is your 4, p is 1 by 3, so q failure is 1 minus success, that is 1 by 3, that is 2 by 3, right? So now we have the probability of success also, failure also, and n also. So p0 means here r is 0. For that we put here r is 0, p raised to 0, q raised to power 4 minus 0. That means q raised to power 4. So it is here 4c naught 2 by 3 raised to power 4. So we can solve this. So we get this. And for your x is equal to 1, that means r is your 1. That is, we are interested to find the probability at x is equal to 1. That x is equal to 1 means your r, that is favorable cases, because this x means this is particular value of your x, that is your r. So here we use for r is equal to 1. So we put r1, that is 4c1, success p raised to power 1, q raised to power 4 minus 1, that is 3. So similarly you can calculate for p2, p3, p4, right? And we know that your mean by standard definition only, not by binomial distribution. This is mean by the definition only. In case of probability, normally we say your xi into fi. But in case of probability in distribution, we use your pi instead of your fi. So divided by summation fi means your frequency, but total frequency, instead of frequency we are here using probability. So total probability is always 1. So the formula is to calculating the mean is your xi into pi summation I running from your 0 to n. So we just multiply this probability with your this number, that is 0, probability multiply with your 1, this probability multiply with your 2, similarly with 3 and 4, and you just can add all these. So 0 into 16 by 81, 1 into 32 by 81, so on. So you can just add, that is your 4 by 3, and we can calculate this by directly using the formula also here, n into right? So one more example we may discuss. So fit a binomial distribution to the following data. Uh, X is given 0, 1, 2, 3, 4, and see here frequency is given, not probability. Frequency is given, but in distribution we have must have here probability. We needed to convert this frequency into a probability. So if this is your data, so we know that you are always for a data, your physical properties are always same, basic properties are always same. That means for the data your mean, variance, total number of entries are always same. You may convert data in a one form to another form. That means you can write data into a frequency distribution, you can write data in a binomial distribution, or more, that is Poisson distribution. But the basic property, that is mean of data, variance of data, they are always unchanged, right? Until unless we can change in data. So here we can calculate the frequency of this by using the frequency this. We can calculate the mean of this by using frequency distribution. And we know that the mean for frequency distribution is your fi into xi summation divided by summation fi. So once you calculate this mean, so this mean is for frequency distribution is also is equal to means for your probability distribution, or that may be your binomial, that may be your Poisson. So because mean is unchanged, so we use this, and the same value we can use for your binomial distribution. So frequency is given, x is given, just use your f into x, multiply 0 into 30, 0, 62 into 1, 62, 46 into 2 is 92, 10 into 3 is your 30, 2 into 8 is your 8. And once you add these, that is 192, and we know that your total frequency is by adding these, that is your 150. So 192 divided by 150 is your 1.28. So this is your mean by frequency distribution, or we say this mean is also is equal to mean of your binomial distribution. This is also is equal to mean of your binomial. You may say binomial distribution, you may represent binomial distribution into P and P, right? So we know that n here is this one, this is your n, that is 4, it is already given to us. So, and we know that the mean in your binomial distribution is represented by n into p. So this n into p is equal to 1.28, or n is 4, so probability of success p is your 0.3. And total frequency is your 150, so capital N is your 150. Now you can, if you have the p, you have the small n, then you are easily calculate or write down your frequency distribution. So here you just require your probability of your x, say is equal to r. So you can calculate all these values, but also we know that your binomial distribution can be represented by q plus p raised to power n, and here your n is your 4. So you know that this if we expand this in a binomial series, your first term represent the probability at 0, second term represent probability at 1, third represent probability at 2, similarly. So we just write this in a form of your q plus p raised to n, so that represent your complete distributions. So never solve the, add these two, because these are always 1, because one is q, another is your p. So 1 raised to power 4 plus 1, you get the 150 only. But once you expand this by binomial theorem, you get the distribution. First term represent probability at 0, second term represent probability at 1. Or if you want to completely show the your distribution, we have the x here, so one more column you can add here, that is your 4C0. You just calculate all these values. We know that how can we calculate probability of success. Success is here, you already calculated 0.32. If this is known to us, then Q we can calculate easily by subtracting from 1, that is 0.68. So you just write down complete, that is P raised to R, that is 0, Q raised to R n minus R, that is 4 minus 0 is 4. So this is your P0. Similarly, you can calculate for your P1, P2, P3, and so after getting these values, this probability distributions is available for binomial distributions. Right? Probability table is. So this is your binomial distribution. One more example, if you like, we can discuss. Assuming the probability of the male birth is your 1/2. So that means probability of success of male birth. If we consider male birth as a success, then it is 1/2. Then probability of distribution of number of boys out of 5 births. Number of boys in out of 5 births. Find the probability that a family of 5 children have at least 1 boy. Second part, at most 3 boy. And B part shows that 960 family with 5 children each. Find the expected number of families with your first part your same, at least 1 boy, and second at most 3 boys. So first we consider here your birth of y is your success. So if x is the random variable, number of y out of 5, number of y may be 0, maybe 1, maybe 2, maybe 3, maybe 4, maybe 5. So probability of success is given here is 1/2. Obvious failure is also 1/2. So the binomial distribution can be represented by your NCR, PR, Q raised to power n minus R. Where this R is moving from your 0, 1, 2, 3, 4 and up to 5. So you can form the table. So that is P0, that is P1, at P2, P3, P4, P5 by using your this upper circle. So first part says at least 1 y. So at least 1 y means number of y should be greater than 1 or equal to 1. That means 1, maybe 2, maybe 3, maybe 4, maybe 5. So all these entries. Maybe this or this or this or this or this. So we needed to add all these 5 entries. So we know that the total probability of system is always 1. So instead of adding, we may say 1 minus this, 1 minus this. That means probability at x equal to 0. So that we know that it is 1 minus 32, 1/32. 1/32 is with subtracting from 1 is 31/32. So that is your probability. Means probability is always from the 1. We know that, right? So in B part, the first part is your out of 960 family of 5 children, expected number of families are. So if we have the probability that is from 1, so from this part, the expected, if we require, we just multiply this probability by your number, that is 960. So you can see here that is your 30. And if you multiply this, that is your 930. So A part, first question answer is your this one, that is probability only. But if you want the number out of your 960, that number is 930. Second part says that at most 3 boy out of 5. So at most is maximum. That means probability at 0, plus 1, plus 2, and maximum 3. So we may do here two things. You may calculate all these four, which is already calculated here in the table. So we just needed to add all these four. Another thing you can do, you can subtract this one from your P4 and P5 from your this one. This is also another option. So once you do this one or this one, yeah, that is your choice. You get your 26 by 32, which is your probability. Probability means out of 1, and B part will require the number of family having at most 3 children out of your 960. So you just need it to multiply by 960 this. So once you do that, just get the number that is your 720. So this is your complete binomial distribution.